Hi, and welcome to the online store with microservices. My name is Carlos Vizcaino. I am a senior software engineering student at the University of Florida, and this video is regarding an independent studies inspired in the microservices architecture. Available, you have my email and the GitHub page for this project. Please feel free to reach out at the end of the tutorial. Thank you. In order to put microservices in practice, let's do it through an example. Let's say that we have an online store web-based application, and this application has three use cases: create a customer account, create orders for a customer, and as well seeing the order history for a customer. Before we go ahead and discuss about microservices, we should talk about monolithic architecture first. What monolithic architecture is combining user interface code and data access code into a single program. However, for web-based programs, it is a bit different. What is considered to be monolithic, it is the server side. The client is just there to render data. The client requests the server for data or sends data to the server based on user input, for example, and the server replies back. This node in here, the server, implements all the business logic. And that's what makes it monolithic. Now, let's say that our online store is a very busy website and we get a lot of requests, right? And we probably want to scale. And the way we will go about scaling a monolithic architecture is to have a proxy node, which is a server that gets an income request from the clients, and then it just delegates the request to the instances available at the time. So the way we're scaling out our one server is by creating multiple instances. Sometimes it makes sense to design our applications in a monolithic style. I'll give you an example. Let's say that when we first started to do the online store program, we did not expect it to get a lot of users. So it just makes sense to develop as fast as possible one single program, which means making it monolithic. However, through time, we got popular and we're getting more users, which means we're getting more traffic in the internet, which means we need to be scalable. The moment we need to be scalable, and it's a requirement for us to be scalable in order for our application to be reliable for our users, that means that we need to start moving from monolithic into a microservice architecture. Monolithic has pros and cons like every other software engineering architecture. The pros are you have a single program, making it easier to develop, making it easier to deploy and test. The cons are it's not so scalable and therefore it's not reliable. As well, monolithic tends to couple a lot of your code, a lot of your business logic, which tends to, through time, make your program not so well to extend. So finally, we get to talk about microservices. Microservices is a suite of modular services in which every single service supports a specific business role. Our online store architecture has been decomposed into three components: gateway, orders, and customers. Every component has one responsibility, and all together they make the application happen, right? That is the point about microservices. So gateway, what does gateway does? Gateway offers an interface to the outside world. Gateway doesn't implement any business logic. The business logic is being delegated into orders and customers. Let's do one of the use cases that we discussed earlier with the online store. For example, when you're going to create a customer. When creating a customer, the user fills the data in the client, and the client sends the data to the interface, right? So the server interface, which in this case is the gateway. The gateway gets the data And it says, well, if you want to create a customer, I'm just going to delegate it to the customer component, because that's the component that knows how to do that business logic. The other use case is when we want to create an order. Again, a client sends the request, hey, here's an order for this customer. The gateway receives that request, and it just delegates it to the order component. Why? Because the order component is the one that knows how to do it. This communication process, or as called intercommunication process, its point is named point-to-point. This design is implying that gateway knows exactly where orders is, and as well where customer is. In the next slide, I would like to talk about a different intercommunication process, and that is called event-driven. So now gateway, orders, and customers, they're all going to communicate to one another through events. So event-driven microservices. Event-driven is one out of the many intercommunication processes that microservices could use. Let's not forget that microservices are individual components that exist totally independent of one another. However, they still need to communicate, and they can use an event-driven system. In this case, I made event-driven happen through messaging queues. Messaging queues give you are very reliable, and they can hold your data, and you can configure them to only throw your data away once you have acknowledged that you have consumed your data. So I'm going to give you an example. Let's say that a customer, from the client side, information is being sent to the gateway that a customer is being created. So the gateway doesn't responsibility in this case is to push that message to a queue, and the next request comes about with the same, right? Another customer is being created and it's pushing it to the queue, and so on and so on and so on. So the queue is going to hold the data, right? So gateway is not concerned, hey, what is going to happen with this information? It's just going to push it to the queue. So that makes gateway a publisher to the create customers queue, and we need a subscriber. We need something that consumes that data and does something with it. And in this case, customer service, it's going to consume that data and is going to store that data into the database. For example, another use case is an order is being placed, right? When an order is being placed, the gateway receives the information, like always. It publishes the message into the queue, and as many orders as it's been placed is going to receive this information and publish to the queue, right? And then we're going to have a subscriber for this queue, and that is going to be order service. Order service consumes this message and does the proper business logic. But now, here is the following example. It's going to show you the power of event-driven. Let's say that a customer has a credit of $30, right? And the order that he just placed has a value of $200, right? So what order service is going to do is, hey, I just consumed that somebody placed an order, right? Let me send a message out in here to an order is being created, and the customer service, its component, it's going to consume this data, right? The information here says I have an order, it is for $30, right? It is for this customer. The responsibility of customer service now is I am going to tell orders whether the order could be purchased or not, because maybe the customer doesn't have enough credit, right, in the account. So order is going to consume that message, and customer service now is going to delegate either one message or the other message. So it's going to check in the database, it's going to get the information for the customer, and it's gonna say, oh, okay, customer only has $30 and the order is for $200. So therefore, I'm gonna say in a credit limit exceed message to orders. So orders, that message, it's being in this queue, and orders is gonna consume that message from that queue and is gonna update the status of the order. So let's say that the status normally at the beginning, meaning here, was placed, right? And here it's gonna be denied, right? So, but let's say that your customer has enough money. So then a message is gonna be published in this queue, and the status, it's gonna be, once orders consumes it, the status is gonna be approved. So what event driven allows us to do in this case is to totally decouple two components, right? The components that actually make the business logic happen, customers and orders. Customer doesn't know that order exists, nor orders knows that, and vice versa, right? And the way that we achieve this is by using messaging queues. Also, notice that every single microservice is using its own database. They don't share the same database. This pattern is called database per service. This is very useful in order to keep single responsibility within your microservices. Your microservices should only write to a database and read to a database. It helps you keep your business logic organized. Well, the tutorial has come to an end. I would like to thank you for taking your time. I hope you enjoy it. I hope you find it useful. Please refer to the GitHub page. You also have my email available, and try to run the application. Try to extend it, and yeah, I hope you liked it. Thank you a lot.